Let's say you're in a movie theatre and you want to know what drives your demand. How do you work out how many people are going to come into your theatre each day? Maybe somewhere, someone said to you that it's related to rainfall. If it's raining outside, people tend to come to your movie theatre. How do you measure that? Well, this is where something called machine learning can help. Now, machine learning itself is quite a buzzword. It's the hype of the analytics industry at the moment. But at its core is really around a mathematical process called regression. Regression itself is also quite simple. It is about understanding the relationship between two sets of data. Really, it's about the slope of a line. You'll recall from primary school maths that the slope of a line can be measured by rise over run. When you plot something on a graph, you get the rise divided by the run, and that gives you the slope of the line. Let's take the movie theatre example. If your ticket sales go up by 100 and the rainfall has been 100 millimeters that day, perhaps you realise that there's a relationship between the two. You can plot rise at the run, 100 divided by 100 gives you a line of 45 degrees. That 45-degree line will tell you something about the relationship between those two sets of data. In this case, it would be a perfect correlation. Not causation at this point, that's a topic for another day. When you take the set of data, if it's nice and simple, like that, you can see a perfect relationship. The reality is it's usually not that simple. In fact, I've never seen it that simple in the real world data. So, what happens when the line's got a slope in it? What happens when the line snakes around? What if the line looks like a massive dots on the page and you can't even see a line? Well, this is where more complex statistical software can help. You can start to plot relationships that you can't necessarily see by the eye. You can remove seasonality. You can do things with the data that becomes more valid for your underlying business, but you can't necessarily do it yourself. Now, the machine learning part comes in when you start to train that data to improve its prediction over time. You can take a set from one year, compare it to another year. You can take a training set, you can take an empirical research set, you can change the prices, you can change the variables in your real world to have a better prediction of what might go on in time. Now, of course, that stuff's all pretty complex and links can help you with that, but really at its heart, it's about understanding what drives your business and using the data that you've got to try and make better decisions.